Hi, welcome to another maths tutorial with Educators Singapore. And the topic of today is differentiation. We are really going to start with the easiest concepts in differentiation and how to solve the easiest problems. And slowly we are going to build up to more difficult problems. So when you have a function y which is given which is a function of f. So when you have y which is a function of f and it's given by fx, the dy dx, this sign dy dx, this means differentiating with respect to x. So this thing, what you get out of it, it's called derivative. What it basically means is that if you have a graph of the function f of x, what dy dx does for you is give you the slope of the graph at any point. But when we are dealing with functions, we are not really going to plot out the graph and find the slope geometrically, but we rather use some algebraic rules and this is like the basics of calculus to find out the slope of a function. So we start with this basic formula that the d dx, which is differentiating with respect to x, of a function which is given by a, which is a constant, and then x. Remember, in all these problems we are differentiating with respect to x. So the function is given by a x to the power of n, and when you differentiate it, this is what it's given to us. The what it becomes is this a n x to the power n minus 1. So we'll learn today how to apply this, the very basic formula, and it's not very difficult at all. So let's take, for example, let's try to differentiate something like 7x to the power of 5. Now if I compare 7x to the power of 5 with the formula above, we notice that a over here is 7, x remains x as usual, and 5 is what is n in the formula. So if we try to apply this formula, we'll be getting a. So if I write down a first, which is 7 times n, n over here is 5, so 7 times 5 times x to the power n minus 1. So n is equal to 5, so 5 minus 1 is 4. So this works out to be 35 x to the power 4. So this is like one of the most basic applications. No, it's not an application, this is the most easiest example of differentiation. Remember, when you have x to the power n and when you differentiate x, the powers of x, you always go lower. In later chapters we'll see in integration you always go higher. So when it comes to differentiation, if it's x to the power 5, you end up with x to the power 4. If it's x to the power 3, you end up with x to the power 2. So you always go down in the powers of x. Now let us look at a slightly larger problem. So suppose I have this function f of x, which is y, is equal to 3x to the power of 5 minus 2x cubed plus 4x. Well, it may look intimidating at first, but there's nothing to be worried about, because all you can do is differentiate each of these terms individually, and as you can see that we have already done it before, differentiating terms like this. So I'm writing out implicitly that these are the terms. So if you differentiate something like that using the formula above, you will get 3 times 5, which is the power, times x to the power n minus 1, which is 5 minus 1, 4. Next term you will be getting 2 times 3 times x to the power 3 minus 1, which is 2 again, plus this one is 4 times the power of x, which is 1, so we don't write it, times 1, times x to the power of 1 minus 1, which is x to the power 0. So basically this term is also 1. So if I write this together, it comes out to be 15 x to the power 4 minus 6x squared plus 4. So we have easily taken a function like this and we have differentiated to get the answer. Now let us look at a problem which is slightly more, I wouldn't say it's more complicated, but it may be a little bit more scarier to look at. So now let my fx look like this. F of x is equal to 3x to the power 4 minus 4 root x. Scary. That's the scary part, isn't it? Times 2. Now look at this. Now you should remember this thing, that the d dx which is the differentiation of a constant, is 0. So when you differentiate a constant, it's 0. So basically, if you think about it from the graph point of view, if y is a constant, so basically suppose y is equal to c, that's what a graph y equal to c looks like. The slope of it is always 0. So that's how you get y equal to c equal to 0. So it's not that it's like some magical thing which you don't understand, but this is where it comes from. So if you look at a graph of y versus x, the slope of the graph is always 0 because y is equal to constant. So when you differentiate a constant, you get 0. So now going back to our problem again. So now, like previous time, I'm not going to write ddx for everything, but I'd rather try to differentiate it straight. So ddx, so look at the first term. Okay, let's write out the terms again, just for convenience. 3x to the power 4, there's nothing which can be done about this, minus 4, we should write ddx of this, 3x to the power 4 minus x to the power half, this is what you're going to write, x to the power half, plus 2. Okay, now I start differentiating. First term, 3 times 4 times x to the power of 3, remember, minus 1. Now the tricky next part, 4 times half, the power is half, times x to the power half minus 1. And the third term, since it's a differentiation of a constant, so I'm just differentiating 2, 0. So the most important thing to look at over here is what I did with x to the power half. So x to the power half, the half came down over here, and then x's new power is x to the power of half minus 1, which is basically minus half. So again, writing down everything really explicitly, 12x cubed minus 2 times x to the power minus half. So all this is works out to be, if I write it in black finally, so this can also be written as 2x cubed minus 2 divided by root x, which is x to the power minus half. So in this video we dealt with the easiest possible problems which can come in differentiation, and in the next few videos we're gonna learn new rules about differentiation when your expression of f of x is somewhat complicated. Thank you for watching this video.